almost ready to finish the unit. So this is the section on linear inequalities. The first thing we need to know is what is a linear inequality. It is similar to an equation, but it uses an inequality symbol. So similar to a linear equation, but uses an inequality symbol. So that's the definition. When we ask for a solution to a linear inequality, a solution is really just like equals something. But because this is an inequality, when we look at a solution, it is any ordered pair that makes the statement true. So let's look at this. If I ask you which ordered pairs are solutions to this linear inequality, which ones would it be? So we are actually just going to plug them in and find out. If I plug in a 2 for x, that would give me 2 times x is 2 minus 3 times 5 is less than 15. So look how I set that up. Here's this linear inequality, but in place of x, I plugged in a 2, and in place of y, I plugged in a 5, which brings me here. So now I'm just going to see, is it true? 4 minus 15. 4 minus 15 is negative 11. Is negative 11 less than 15? Yes, it is less than 15. So this point checks out, and it makes that statement true. Let's look at negative 1. If I plugged in a negative 1 for x and a negative 7 for y, does it make that linear inequality true? Negative 2 plus 21 is 19. Is 19 less than 15? No, this does not check out. And again, you don't have to rewrite it. You can use your common sense and plug it in and say 2 times 3 is 6. Negative 3 and a negative 4 is positive 12. 6 plus 12 is 18. Is 18 less than 15? No, it's not. So this one is not true for that linear inequality. Let's look at 0. 0 minus 0. Is 0 less than 15? Yes, it's true. Now, out of all of these, which one was the easiest to do in your head? I'm going with 0, 0. So we're going to come back to this 0, 0 as we start checking our answers. So hopefully put that in your notes. All right, let's look at, when we graph linear inequalities, we still want to put it in the form y equals mx plus b. That's how we know to graph. That's what we've been doing. So our first step is we're going to put the inequality in slope-intercept form, which, remember, is y equals mx plus b. And my inequality still holds true. Remember when we did inequalities and we multiply or divided both sides by negative? Do you remember what happened? We flipped our signs. The same holds true. That doesn't change. So we were going to do that as well. Step 2 is we're going to graph the line. We've been graphing for a while now, so we're going to graph that inequality. We are going to use a solid line for greater than or equal to and less than and equal to. And it's very similar to when we did inequalities and I said, like, if 5 is x greater than or equal to 5. When x was greater than or equal to 5, we bubbled it in, right? Because 5 was a solution. And if it was just x is greater than 5, we did an open circle because 5 was not a part of that solution. It's very similar to this. If it is a solid line, it means that linear equation, that linear inequality, that line itself is a solution. But if it is a dashed line, greater than or less than, it is not a part of that solution. And we're going to take a look at what that looks like. All right. Now, that's when we graph the line. As far as shading goes, we are going to shade above the line for greater than or equal, and we are going to shade below the line for less than or equal. All right, so now that we have the rules, let's take a look what that looks like. So here's my example. This is not in slope-intercept form. So my first step is to put it there. I'm going to get y by itself. So I subtract 2x on both sides. I get negative 3y is less than negative 2x plus 15. And I divide by a negative 3. Now, because I'm dividing by a negative number, I've got to flip my sign. And I'm left with y is now greater than positive 2/3 x minus 5. Okay? So I still have a beginning point as negative 5. And my slope is still positive 2/3. So I'm going to go up 2 over 3, up 2 over 3. Now, this is where I need to remember my rules from above. It is greater than. So that means it's going to be a dashed line. I'm still going to use a straight edge, but I'm just going to dash my line, not give it a solid line. And here's what I want you to remember about your skier. I want you to draw a picture of your skier. Remember, all mathematicians ski left to right, so I'm always drawing my skier on the left-hand side. The shading, we have to shade above, so it says y is greater than. So if it's greater than, I shade above my skier. So I'm shading above my skier in all this region. So this is your answer. It's a graph. You couldn't possibly name all of these points, right? Because it would expand infinitely many times. So this is the solution. It's all of these points that are shaded. That's the solution. So I'm going to check it. And I'm going to check it by using the easiest point of 0, 0. So 0, 0 is inside the shading. So 0, 0 should be a solution to this. So if I plug in 0 for x and 0 for y, that gives me 0 is less than 15. Is that a true statement? It is. Therefore, I know that I have shaded in the correct position. So that's a way you can check your answer. All right, let's look at number 2. I'm still going to graph negative 1, and my slope is negative 2. My slope is negative 2 over 1. My beginning point is negative 1. So from my beginning point of negative 1, my y-intercept, I go down 2 over 1, down 2 over 1, down 2 over 1, and then I'm going to reverse it just to make sure that I'm doing it correctly. And my line, because it's less than or equal to, it is now a solid line, which means that these dots can be solutions to that line. They absolutely can be. It's a solid line. Now, let's locate my skier. It's a negative slope, so my skier's up here. And now it says y is less than. So if it's less than, you shade below the skier. Okay? Now, I'm going to grab a test point. If I grabbed 0, 0, should 0, 0 be a part of this shaded area? It shouldn't be because it's located outside here. So now, if I use 0, 0 as my test point, because 0, 0 is easy, if I use it, it should not make that statement true. So let's try it. Is 0 less than or equal to, this is 0 minus 1. Is 0 less than negative 1? No, it's not. 0 is greater than negative 1. So that is true. If that gets a little too confusing, you can always choose any point that's shaded and check your answer. So maybe you want to check negative 5. 1, 2, 3, 4, negative 5, 0. So should negative 5, 0 be a part of this solution? Yes, it should. So let's check it. So y is 0, less than or equal to negative 2 times the negative 5 is 10. 10 minus 1 is 9. Is 0 less than or equal to 9? It is. So I have shaded in the correct position. Okay, so I showed you 2 ways to check it, right? Okay, let's do a couple of other examples. So number 4. I'm going to get y by itself because I'm going to graph it, so it needs to be in y equals mx plus b form. I'm dividing by a negative 4. So when I divide by a negative, I've got to switch my sign. It becomes greater than. So y is greater than 1/4 x minus 2 once it's simplified. So my beginning point's -2. My slope is positive 1/4, so I go up 1/4, up 1/4, and I'm going to repeat that pattern on the other side by going down 1/4, down 1/4. And then I ask myself, is it a solid line or is it a dotted line? Because it's just greater than, it's going to be a dotted line, a dashed line. I'm still going all the way through, arrow on both ends. I'm going to draw a picture of my skier. So the positioning is here. He's going uphill. So where am I going to shade? Well, it says that y is greater than. So I'm going to shade above my skier. And that's my answer. Now when I use a test point of 0, 0, should 0, 0 be shaded? Yes. So let's check it. 0 minus 0. Once I multiply all those zeros, is 0 less than 8? It is. And I've shaded correctly. Let's jump down to number 6. I'm going to get y by itself, so I subtract 3x on both sides. I get 2y is less than -3x plus 0. Divide everything by 2, and I get y is less than -1, no it's not, -3/2 x plus 0. So that just tells me my beginning point is 0. My slope is down 3/2, down 3/2, down 3/2, and now I'm going to reverse it and go up 3/2, up 3/2, up 3/2. So now I have my dots. Because y is less than, that means it's not equal to, so I'm going to have a dashed line. Here's my skier. And because it's less than, I shade below. So 0, 0 is right here. 0, 0 is on a dashed line. So 0, 0 is really not a part of my solution. If you plug it in, it says, is 0 less than 0? No, 0 is not less than 0, it's equal to. So my test point is on that line, but it's not a part of my solution. All right, last one that we're going to do is 7 and 8. So if you have y is less than or equal to -4, here's -4, and it's a solid line because it's equal to. That's what my line looks like. Here's my skier. And is y less than or greater than? It's less than -4. So what are some numbers that are less than -4? All these underneath the skier, and that's what it looks like. Look at my graph of y, x is greater than 7. So here's 7, 4, 5, 6, 7, and it's a dotted line. And I have students ask me all the time, well, which way do I shade? Which way do I shade? Don't lose track of common sense. If this is 7 and x is greater than 7, what numbers are greater than 7? Are these numbers greater than 7? No, these are like zeros and negatives. These numbers are greater than 7. So we're going to shade that way, okay? So that should get you through linear inequalities. Good luck.